showing our Arduino biped robot. And so the problem here is the objective of this project is to design and build a biped robot that can walk forward and in reverse when it recognizes obstacles in its path to avoid running into them. The robot should be powered and driven by Arduino controllers, aka the servo motors, and they should operate autonomously. The structure of the robot should be designed in CAD and manufactured from any of the processes available to you in the engineering lab, including but not limited to 3D printing, laser cutting, and CNC. All work should be original, and you may use others' projects as inspiration and guide. And so we chose to laser cut cardboard for our body, which you will see later.
Alright, so the design specifications, the robot has to be durable, has to be able to withstand a high fall, and it should be able to work the same way. We can't use tape, string, or any temporary joinery. That's pretty straightforward. Robot should be able to be programmed to adjust. To adjust the distance by which it reacts to the obstacle. Robot should clearly have 2 legs, which serve to provide walking motion. Robot should be able to spot an object in its path, so our robot can do most of that.
So we had 5 viable designs based on our research and the criteria that we were given. And so concept 1, as you can see right there, so this concept used 4 servo motors for the legs, a 9-volt battery, a sensor and Uno board, and male wires. Now this design gave good structure for how the robot would move effectively, and also left room for us to creatively manipulate it. And yeah, so that's, we kind of, yeah. So then we have concept number 2, which this one had only 2 motors for the legs. And I have the servo motor and the ultrasonic sensors, as you can see, with the feet and the eyes. And it had most of the same components as the first one, it just looked different. And as we moved into concept 3, this one had 5 different motors with 2 at the feet and the ultrasonic sensor at the very top. Instead of placing the Uno board inside the robot, it would instead be on the side or hang off the back side. So that's what was different between concept 3 and concept 1 and 2.
Without moving your index finger.
Yeah, very slowly. Oh shoot. And then with our concept 4, this concept is a little bit more doable, as it also uses attainable resources such as cardboard to build the body. And the supplies that this robot needs is 1 Uno board, 4 servo motors for the legs and roots, 1 male jumper wire, and a breadboard. This design simply does meet the criteria because it's simplistic and does not need too many materials or brain cells. Alright, concept number 5. This is the last concept that we came up with. It's more of a niche design, but as like this design had like body parts that would be 3D printed, but the moving components would be the same as the last 3 concepts. This concept did meet our criteria in containing the sensor and moving forward and backward when it would detect any objects in its path.
So all of our designs kind of accomplished the same thing, but they all kind of just had a little piece here and there that was different. And so ultimately, the one we went with was concept 1, but we kind of manipulated it more to fit what our brain cells could accomplish. And so we'll show you ours in a minute.
I think for a while.
And then,
take a pen.
so our project results is our robot kind of walks. It's not like a fluid walking motion, but it does move. It more dances instead of walks. And then,
the sensor, it works, But the thing about the robot is that the way it walks, doesn't.
It's fine. Keep going.
The robot doesn't react the way we want it to because of the program for all of the motors, so it doesn't react right. So
Yeah. So we encountered a lot of issues with this project. One of them being the first Uno board that we grabbed, it actually didn't like upload to the computer right, and it didn't sync to the computer. So Mr. Freddy had to give us a completely new Uno board. And then with this specific Uno, I think it's the 101 board, you had to go in through like these big, long, complicated things that I don't know because Mr. Freddy had to do them in order to be able to code using the Uno board. And so that was one of the main issues we had. That took a lot of time. And then
we also had the laser cutting the body. The measurements, they were kind of off a couple of times, so we would have to redo it, and that took some time. But the good thing about it was that it was made out of cardboard, so that didn't really take too much out of us, especially since it was primarily made out of a huge cardboard box. So.
And then also the issues with the servo motor was we ran into a slight issue we coded the motors without compensating for how we connect the servo motor or the sensor to the Uno board along with the other motors. And so, but we eventually kind of figured it out. So here is, no, never mind.
Alright, so that's supposed to be the video, but appears that it's not loading, so we'll try to find a way to send that to you. But it should be a video of the robot walking and reacting to the sensor.
Oh god.
No.
So as you can see, it's moving. Not very nicely, but it's moving. Yeah, that's our robot.
So as we mentioned earlier, we wanted to have the robot react with the sensor, but since the robot tends to walk like that, we didn't really get like the normal reaction that we would have wanted it to. So a lot of the times we would have the robot fall over on its side, on its back, especially when the objects were in the way. So that either could have been it reacting from the objects of its path, or the robot program just wasn't correct, and that really was a downgrade from how we designed it.
So yeah, as you can see, we put a lot of effort into making it look kind of like a robot, where the sensor looks like the eyes, and it looks pretty pretty. If you look at it, it's kind of clean, you know, not very ugly. But yeah, and then the wires are his little hair. Okay, bye vlog. Hey vlog, it's Maddie and Lauren. We're back, and so we're starting presentations on Monday. So we're kind of doing the final touches on our robot, and so that's what she looks like through another camera. And that's what she looks like. She slightly works. We're figuring that out right now, trying to get it to fully function. But we'll get there. So we have her working to a degree where like we feel comfortable turning it in, but we're gonna try and fix it up some before we have to present. That way we get like, you know, maximum points, because we have tried and we have worked on this despite, yeah.